All right, page 3, 28 to 38, graph x squared plus 3x plus 2, identify the vertex and the axis of symmetry. So we are going to, this is standard form. Let's see, can we factor this? Sometimes that makes it easier to graph it. X plus 2 and x plus 1. Does that give me my zeros? It sure does. 1x plus 2x is 3x, so I have x is equal to -2 and -1. Those are my zeros. -2, -1. My vertex is going to be halfway between there. I can do -2 plus -1 divided by 2, which is -3 halves, and then I need to plug that in. -3 halves squared, that's my vertex, halfway between my intercepts. I could have also used -b over 2a, and I would have gotten the same thing. So -3 halves squared plus 3 times -3 halves plus 2. That's 9/4 minus 9 halves plus 2. We'll get a common denominator. All right, so let's get our common denominator. Times by 2 to make that a 4, times by 4 over 4. So we get 9/4 minus 18/4 plus 8/4. Now I get -9/4 plus 8/4, which is -1/4. So that's right there, tiny little point. My vertex here is at -3 halves and -1/4. So that's also my axis of symmetry at -3 halves. We know if we plug in 0, we get +2. So +2, let's reflect that. And that gives us a pretty good parabola. And there we can say, it didn't ask you about domain and range, but my domain is always all real numbers. And my range is that y is greater than -1/4, greater than or equal to -1/4. Graph y equals -3x squared plus 6x plus 5. Does the function have a maximum or minimum? We can answer that question, maximum or minimum, just by looking at the negative sign. That means it opens upside down. So it has a maximum, and we can find it by finding the vertex using -6, -b over 2a over 2 times -3, -6 over -6. The x value of the vertex is -1. That's not the maximum or minimum, it's the x value that gives us the maximum or minimum. So let's plug it in. -3 times -1 squared plus 6 times -1 plus 5. That's -3 times 1 minus 6 plus 5. -3 minus 6 plus 5, -9 plus 5, -4. And so my vertex is at -1, -4. That's not right. Okay, so I made a mistake, but I want to talk through it because I think that's a good part of the learning process. What did I do? A negative times a negative makes it positive. This point doesn't have to get thrown out. It's on the graph, -1, -4, but it's not my vertex. So I'm going to put it on here, over here. My vertex is +1, so let's plug that in. 3 times 1 squared plus 6 times 1 plus 5. That's 3 plus 6 plus 5, a -3 plus 6 plus 5, that's 3 plus 5, which is 8. So my vertex is at 1, 8. That makes more sense. So 1, 8, there's my axis of symmetry, and I can use that point that I plugged in incorrectly to reflect that. And that gives me a pretty good picture of the graph. I could plug in another point. When I plug in 0 plus 5, I get 5, so 0, 5. And we can use that symmetry. And there is our graph with a maximum of 8. So you don't always have to just scrap a point. If you plugged it in and you realize you made a mistake, You can still use that point on your graph, but you have to make sure you find the right vertex and pay attention to those signs. All right, number 30, divide using synthetic division. This says 6 plus x. I can make that x plus 6, so x is going to be negative 6. Don't forget you want to solve that equal to 0, and that's what you're putting in the little box. You have to represent all of your coefficients. This is not in order, so we need to put it in order. The x cubed is first, that's a 1, plus 3x squared minus 11x plus 4. Now my coefficients are in order. I'm not missing anything, so I don't need zeros. So I get 1. 1 times negative 6 is negative 6. 3 plus negative 6 is negative 3. Negative 3 times negative 6 is positive 18. Negative 11 plus 18 is 7. 7 times negative 6 is negative 42. And 4 plus negative 42 is negative 38. So I get, this is my constant, this is my remainder, this is my x, and this is x squared. It's always going to be 1. If I'm dividing x by x cubed, my answer has to start with x squared. So it's x squared minus 3x plus 7 plus my remainder, negative 38, over what I divided by x plus 6, or 6 plus x. That's my answer. Number 31 says solve 6x equals 9 plus x squared. I'm going to move my 6x and put it in order. I get x squared minus 6x plus 9. I should recognize this as factorable. X minus 3, x minus 3, and then solve. Just factoring is not enough. X minus 3 equals 0, so x equals positive 3. There's only one answer because it's a perfect square trinomial. So let's move this up. Solve each inequality, describe using a set notation. So beautiful bell. 32. Absolute value of x minus 2 greater than 4. Let's see, greater than is an or, so I want x minus 2 greater than 4, or x minus 2 less than negative 4. Add 2, x is greater than 6, or x is less than negative 2. On the number line, negative 2, open circle, less than 6, open circle, greater than. Okay, number 33. Let's make a little bit more room here. The absolute value of 2x plus 3 is a less than or equal to 5. Less than is an and, so it's negative 5, less than or equal to 2x plus 3, less than or equal to 5. And we'll subtract 3. Negative 8, less than or equal to 2x, less than or equal to 2. Divide by 2. And negative 4, less than or equal to x, less than or equal to 1. And graphing that is on a number line. Negative 4, closed circle, a 1, closed circle, greater than 4, and less than 1. That's everything between negative 4 and 1, including it. Some of this stuff up. Number 34 is an absolute value equation. You just delete that out of their way. Absolute value of 6w plus 3 equals 9, so we write our two equations. 6w plus 3 equals 9. 6w plus 3 equals negative 9. Minus 3. So 6w equals 6. 6w equals negative 12. Divide by 6. And w equals 1. And w equals negative 2. And then lastly, find the value, each value if f of x equals 3x plus 2x squared, and g of x is negative 4x squared plus 2x minus 3. Wants us to find g of a. That means we're going to replace all of the x's with an a. So 35 is just negative 4a squared plus 2a minus 3. And that's your answer for 35. Okay, so this system of equations, I have all x's with a coefficient of 1. So I'm going to use equations 1 and 2. I'll multiply equation 1 by a negative 1. So I get negative x minus 2y plus 3z equals negative 5. I'm going to add that to the second equation, x minus 2y plus 2z equals negative 3. And I get, wait, that's not a 2y. It's just a y. So I get negative 3y plus 5z equals negative 8. And then I have to use equation 3, so I'll multiply that one by a negative. Negative x minus y plus z equals negative 2. Make sure all your signs are right. And I'll add that to the middle one, x minus y. I actually want to add it to the top one, x plus 2y minus 3z equals 5. And the x's eliminate, I get positive y minus 2z equals 3. And I can multiply this one by a 3 and combine it over here. 3y minus 6z equals 9. And I get negative z equals 1, so z equals negative 1. Then I can plug that back in. Y minus 2 times negative 1 equals 3. I'm plugging it into this equation because the y has no coefficient, so that's easier for me. And, well, not necessarily easier, but just less work. So y plus 2 equals 3, so y equals 1. And then we'll come back and plug it into equation 1. X is what we're solving for, plus 2y, that's 2 times 1, minus 3 times z, which is negative 1, equals 5. And we get x plus 2 plus 3 equals 5. X plus 5 equals 5. And x equals 0. So my ordered triple is 0, 1, negative 1. And that's my answer. Number 37, solve the system by substitution. So on this first equation, I'm going to get x by itself, so I'm going to add y. So I get x equals y plus 6. Then I'm going to plug it in. 3 times x, which is y plus 6. I'm substituting this in for the x, plus 2y equals negative 22. Distribute my 3y plus 18 plus 2y equals negative 22. And that's 3y plus 2y is 5y plus 18 equals negative 22 minus 18. And 5y equals negative 40. So y equals negative 8. And if x equals y plus 6, that's negative 8 plus 6. So x, equals negative 2, and my ordered pair is negative 2, negative 8. Should have done that over. And then we'll move this over a little bit and make some room to graph. So this equation, I need to get y by itself for the first one. So I'm going to subtract x, and I get 3y greater than or equal to negative x plus 6. Divide by 3. And negative x divided by 3 is negative 1/3 x plus 2 greater than or equal to y. I only flip the inequality if I divide by a negative, which I did not. So now I have the two equations I need to graph. Positive 2. I'm going to go down 1 and over 3. Down 1 and over 3. And this is a solid line. And then my other equation is at negative 2. I'm going to go up 3 and over 2. Solid dashed line. the dashed line is less than, so that's down. The solid line is greater than, so that's up. So where is the shading in common? That's over here. Draw that a little bit. Less than, greater than. So the shading is just where we have the highlighter.